In this video, we'll be going over equations of equilibrium as well as the process needed to solve 3D equilibrium problems. Earlier, we know that when an object is in static equilibrium, the summation of the external vector forces and the summation of external moments are equal to 0. We can also rewrite the summation formulas using Cartesian coordinates, where the value before the I is the summation of x-force components of the vector force or moment. This is the same for j and k, but with y and z. By definition, the I, j, and k unit vector components are independent. Thus, we can write 6 equations of equilibrium. Keep in mind that these are all scalar values. Now, let's take a look on how we can solve problems using equations of equilibrium. The first step that we want to do is always sketch a free body diagram. When we draw the FBD, we want to make sure we show all of its dimensions, body forces and orientation, and external forces and moments. These are usually given in the question. We also want to show all of the unknown reaction forces, connection forces, and contact forces. For the unknowns, we want to assume a sense to be confirmed during calculations, and we want to choose x, y, or z axis location and orientation to simplify our calculations when we find reactions or apply forces at a support. We want to make sure we orient parallel to as many forces and moments as possible. Step 2. Now we want to apply the equations of equilibrium. There are 2 different approaches. Let's talk about the first one, which is using the vector approach. If force components and/or lever arms are too difficult to compute, we would use the vector approach. To use the vector approach, we can write out the 2 summation equations, the summation of the force vector and the summation of the moment vector, and then we all equate them both to 0. We learned this earlier in the course, where the vector moment is also equal to the position vector cross the force vector. After we plug all our values in, we can use the equations we just set up and write out the equations in Cartesian form. The second approach is using the scalar approach. If forces, moments, and lever arms are already resolved to its x, y, and z components, then we can use the scalar approach. The scalar approach uses the summation of forces in each direction, and the summation of moments in each direction. We have 6 equations for 6 unknowns, so we can only solve problems that have less than or equal to 6 unknowns. If the number of unknowns is greater than 6, then the structure is indeterminate and cannot be solved by the statics above. That concludes everything you need to know in 3D equilibrium. In the next video, we'll be looking at an example related to this.